So welcome back. This is the continuation of what we did in the last class. We were talking about sparsity of a matrix. We talked about dense and sparse matrices. We said for a sparse matrix you have more zeros compared to non-zero values, while for a dense matrix you have more non-zero values compared to zero values. And we're looking at sparsity. We said sparsity generally lies between 0 and 1. So the closer it gets to 1, the more sparse the matrix is. That means the more zeros we have, and the closer it gets to 0, the more dense the matrix is. So generally we say a matrix is actually sparse when the sparsity is greater than 0.5, but it is dense if the sparsity is less than 0.5. So how do we calculate the sparsity of this matrix? For you to compute the sparsity of a matrix, this is a formula you basically make use of. Sparsity is equal to the number of zero values. So it's equal to the number of zero values divided by the total number of values you have. So number of zero values, don't mind my writing, once again I'm not using a good pad. Number of zero values, okay, all over number of items in the matrix or in the array. Okay, so that's what you call sparsity. So for example, if I look at this, the sparsity I have, number of zero values I have is 3, total number of items I have is 4, so the sparsity I have is 0.75. So for the fact that I have a sparsity of 0.75, it means this matrix is actually a sparse matrix, okay, because the sparsity is greater than 0.5. For this, the number of zero values I have there is 3, total number of values I have there is 9, so this is 0.33 approximately. So since I'm getting something less than 0.5, it means this matrix is a dense matrix because I'm getting something less than 0.5. For this, if I look for the sparsity, I have 6 values, right? 6 divided by 9. So 6 divided by 9, this will give me 0.67. 0.67 is actually greater than 0.5. For the fact that it's greater than 0.5, it means what I have here is sparse. So it is the number of non-zero values all over the number of items you have there that's going to give you the sparsity. Now another formula they use for the sparsity, which we are going to use when we come to the practical aspect, most of the times that's what we are going to use. Okay, so the sparsity, another formula we can use is to say it is 1 minus the number of non-zero values divided by total number of items we have. So this is going to be divided, sorry, this one is taking everything here, so this is 1 minus number of non-zero values. I think I should just wipe that off so we won't make any mistake there. So yeah, so we have it to be all divided by this part divided by the number of items. Okay, so this is another way we can compute the sparsity. We are going to use that in the next when we come to the practical aspect. So this is it. Just go ahead and compute, look at different matrices and compute their sparsity. Okay, I don't want to dive more. Sparsity is something that is quite vast, okay, especially when it comes to machine learning. So I'm not going to dive deep into that for now. Just know that something like that exists, and this is how you compute to determine the sparsity of a particular matrix or an array. So in the next video we are going to be focused on the singular matrix. We'll talk about the singular matrix. Okay, so I'll see you guys in the next video. Bye bye.